investors. Currently reading several books from Bill Gates' reading list and love to be the courageous in nature. She has delighted, believed in her skill to move progressively at every step in her career. Being proud about being a woman of color who has strived hard to be at this place. I would like to welcome Shushmita Nagarajan to take over the session.
Hello, sir. Good morning. Thank you for presenting. Okay. I will start presenting my screen.
I think her connection it has been disconnected. Just wait, she is back. Shushmita, your voice is not audible. I think your mic is in unmute. Sorry, you want to unmute.
Okay now?
Yeah, it's okay. You can go ahead.
Thank you. Sorry about that again. Okay. Okay. My name is Sushmita Nagarajan, and I'm working as a senior data scientist with this company Rakuten in US. I live in Seattle, Washington right now, and I'm going to be talking today more about data science and how it is evolving and what actually we do in industry with this so-called data science and what are the procedures and techniques we follow to adapt this process. Okay. So to talk about me, I studied in JPR Institute of Technology from 2011 to 2015. Prakash sir was my HOD for all the 4 years, and he has guided me evidently for 4 years in the future. And he has helped me understand many concepts of computer science very clearly and evidently. So he's a great part of my success journey, and I really thank him for that and this opportunity right now. I'm from Chennai, and I'm a very curious person by nature. I like to know more about a lot of interesting things. And yeah, that's just about me. And okay. Let's talk about what are the use cases we have for data science in the recent times. So take every field. So in image analysis, suppose if you have a normal picture, you want to identify, say you have a picture of a cloud, you want to find what's the shape of the cloud or what's the current altitude or where that particular cloud is shaped and what is the climate looking like and everything. You just put that in some kind of Google an image thing, and it would be able to tell that this is the particular cloud and this is the particular shape of it. You call it cirrus, or there are a lot of shapes of cloud forms and things like that. So you can easily identify that, say, an object, say if you show a mango in front of a camera, it's been able to detect as a mango or things like that. That's because of the object detection and image detection in data science and machine learning. And that is one of the use cases that we commonly see in recent times. And the second system is user advertisement behavior. So in Facebook, Instagram, or whatever be, even your web search advertisements and things like that, you are prominently able to see more advertisements that are more close to things that you have looked up on before, or what you try to, or what you think you would want in the future. It's mostly based on the words that you type in the phone. Say you allow your keypad to be noticed by, so if I type the word, I am looking for iPhone, to my friend who I'm just talking, so the word looking for iPhone is being tapped. So it's been taken by Instagram's features, and it's able to give us relevant ads based on that. So there are a lot of things which people are trying to personalize advertisement just for you, just for the particular person, whoever is using the phone or that application, so that it's more user centric and it can provide more utility than just providing some random ads of things that you might not even need in the future. So that is another thing that we're seeing in real life. And the third thing is that the virtual assistants on chatbots. So initially, chatbots used to be like, whatever you say, it just responds like, it just has like a predefined set of answers. It would just say, okay, this is what you have to follow if you cannot pay this amount in the bank. And if you're talking to a chatbot, it would just tell like, you have to follow this procedure, and it would just tell irrelevant answers which are not going to help you at all. But in recent times, what's been happening is that there is more of cognitive learning, where it's able to understand your sentiment, it's able to understand the seriousness of what you're talking, and it's able to give you more answers, even more relevant, rather than just throwing out some random sentences out there. So that's the another use case. And we see website recommendations. So say if you're seeing a video in a YouTube, the other videos that come to you are mostly based on the behavior of how they think you would like the content and things like that. So that's another important use case that we are experiencing in YouTube and other websites. And the fourth thing is about predictive analysis. So say if I'm having the sales of this company called Walmart at this particular percentage, so what I think the sales for next Diwali would be in this particular company called Walmart. So how I would predict and things like that. These are the common use cases that we're seeing in everyday lives. And in every part of this, we have data science. So data science uses the same underlying principles of math, statistics, coding, and everything. It's so simple. It's just the same computer science topped with more math and statistics to make it even more decision friendly and more data friendly. So we arrive at a conclusion based on some math and statistics and just not some random facts. So it's the basic computer science algorithms that we all know, and we're just using more ideas of math on top of it to help us deviate to the right decision. So that is what data science is all about. And okay, so I want to tell, as I was telling, data science is basically just about math and statistics, right? So what is happening in the normal field of computer science and how data science, machine learning, and things like that work. So I like to give more detailed explanation here. So I would say the branch called AI, artificial intelligence, has multiple branches. One could be visual augmented reality, and one could be robotic systems. One would be data science, machine learning, and so many things around it. They're all coming under one branch called AI, artificial intelligence. And computer science has different arenas. Computer science has an arena called gaming, they have arena called e-commerce, they have AI and things like that. So in one of the arena of AI, data science just falls under. And many a times there is also a confusion between data science and machine learning. So data science and machine learning coexist with each other. They both carry similar ideas and the practices and the algorithms that we're using. It's just the way how we are training the models. Data science is more data centric, and machine learning is more algorithm centric. So I will give a use case. So suppose if we are going to use Walmart prediction analysis for sales. So I'm going to take this store called Walmart, and I'm going to predict. Now I have data about Walmart for the last 2 years, and I want to predict how the sales is going to look like for Walmart for the next year. So I have this use case, and how data science is going to come here is that I'm going to take the data from the last 2 years. I'm going to see what is the useful information out of the data, and how I can derive the particular insight from the data, and how I'm using visual tools, like say if I'm using a pie chart or if I'm using a scatter plot to understand the details of the data. It is data science. So the algorithms that I'm really using to understand the predictive analysis, say if so we have 2 years of Walmart sales data, in which we have data involving festival time sales and sale events, like we have about okay, so we are trying to sell this new product, which is a suite for Diwali next year. And we already ran 2 kinds of sales for the last 2 years. And we also had a promotional event on last 2 years where we had buy one, get one free and things like that. So now I'm using a model called linear regression or logistic regression. And I'm trying to understand what is the dependent variable and what is the independent variable. So basically, I'm trying to see was the promotional event important factor, or was it just the suite, or was it the price, or was it the location where the Walmart store was, or maybe because they had like a campaign running and they had like small carts everywhere where they could help people easily access the suite. So what is the reason for the sales? If I'm taking so many data points of consideration, I have the data for the particular time of the year. Say it was the festival season around September. And secondly, I was having, say, the locality. So I had this Walmart shop in Ananagar where people of different income category live. So I know that people are able to afford this, so they were able to buy that. And I also know that say that particular year I had an offer, so it was not just the actual price. People were ready to get two for the price of one, so I know there was an offer going on. And I also know that that the quality of the product, say we have this renowned brand already, and that is why it was selling. If I promoted a new brand, maybe people wouldn't have cared to buy that. So that's another factor. And I have like 100 different factors in the same data. So this is data science. So I'm using different data and I'm understanding data points and I'm trying to get them to a solution. Where I use machine learning exactly in here is that the algorithm. So I'm going to write a formula telling the independent variable is X and the dependent variable is Y. So I have to understand how much X and Y are interrelated, so that if I know in the future, even if I don't know the value of one particular variable, I would be able to predict the value of another. So in this scenario, I'm trying to apply a math formula and I'm trying to understand an algorithm on some data. So I'm sending the data to an algorithm, to a model, to understand how the relations work, and it is able to give some calculation. And that part, that centerpiece, is what I call machine learning, because that is the whole part that derives the whole solution for the data. So the whole process is AI, and the part where we use data science is gathering data points and understanding the importance of data. And where exactly we use machine learning is that we understand how the algorithm is working, we know the formula, we do the math, and the solutions we get some solutions. So this is how the overall problem statement looks like. So from start point to the end point, and how I address to the problem is little different than how I see a computer science problem. So a computer science problem could basically be like, if I'm trying to find a route, say we all know Digitrax algorithm and algorithms like to find distance between 2 points and things like that. We know the values, we don't deal with unknowns. So we know from A to B, how is the distance, distance, we know the number of nodes visited, and we know how to traverse, and we could be smart enough in understanding what is the shortest path by traversing in a different way. But we wouldn't be doing without knowing the start point and the end point. That is not how computer science works. We deal with a lot of knowns. We don't deal with unknowns. And machine learning and data science deal with a lot of unknowns. So when we use a lot of unknowns, that is when math and statistics are important to understand what is the exact piece of problem that is missing and what we have to find about the future. So when I'm able to think that, say, for next September 2021, what I would be needing, I need to know how the company has performed in the last 2 to 5 years, or whatever kind of data that is sufficient, or like which I think is present. I would just take that and make some computations. So this is why math and statistics are really important, because first of all, we need to understand some kind of inference from that, and we cannot just make a decision based on a random fact. We need an actual number on the data, or on the fact. So once we have a number, say an accuracy or a precision or a recall or some kind of a score, that is when we are able to take a decision. So we know the model is performing good when the accuracy is more than 80% or like 60% or however, but we have a number there. That is when we are able to get better solutions. And the third point is that we're able to analyze the data. So on the overall sales data that we had for the last 3 to 4 years, I was able to see a lot of data points. I was able to see the locality. I was able to see people's buying capacity. I was able to identify the promotional offer attached with that particular thing that I was having. And I also saw like a lot of different factors from just one supermarket store sales that I was trying to predict for 1 month on a festival season. So I was able to identify so many data points from just a normal source of data that was given. Say if you have 10 data points, like you just, a company maintains like a ledger, like a CSV sheet telling that date July, this is the sales, and this is the actual loss, actual profit. These are the things that are sold. The highest sold product was this particular thing. And that month, mango was the most sold thing, and what we ran promotions and how the shop function and things, that just from the basic data of the store. Say we just had 10 rows and 10 columns, but I was able to make 100 different data points from the same 10 rows and 10 columns. I was able to integrate everything and make it into a broader scale so that I could understand each and every piece of the data even more clearly to make a decision. So I can understand and analyze the data more when I use math and statistics. And we need some, as I said before, we need some kind of a number to understand and predict, rather than just get into a conclusion just by thinking that that would work. So we are using science to help us with decisions, and that's why I think math and statistics are really important for data science. And okay, so as I was telling you how computer science works and how math and statistics is and how data science is, they all coexist with each other. So we have to first understand the basic concepts of computer science to go on with data science or machine learning, because that's really important for us to understand how things actually work and how you're going to. So you have to know how you deal with knowns when you want to know how to deal with unknowns. So you have to be really strong with those principles of, say, if I don't know how well, if I could be using a 3-line code for like understanding the computation of finding the shortest distance. So if I'm writing program for 10 lines just to identify the shortest distance between two nodes, so the 10 lines is making it space complex, time complex, and a lot of other complexities come into it. But only if I know the computer science, the algorithms and data structures right, I would be able to write 3 lines of code, which I'm trying to minimalize. And then when I apply my system of unknowns with math and statistics, it would function better. So if I already have a laggy system, it's going to make it even more slow and less less performingly great. So we have to know about computer science well, and we add math and statistics on top of it to help us give decisions. And there comes data science. We could use it on different domains. And okay, as we know about data science, we have three important points of data science. So once I was talking about the sales prediction problem that we were going to deal with. So I took some amount of data from the company that they gave me. I understood what kind of data points that I needed from it, like sales, like location and things like that. I took all of the data points that was needed, and I also understood that many of the data that was in the data given by the company was not actually worth it. So I discarded the unknown. I took only the things that I thought was valid. I trained my model on that. So the model is going through a phase called training, where it is going to understand that okay, so 2 years of data is given to me, and it would do all the kind of relation between the dependent and independent variables, and it would help me test or predict. So I'm going to show you an okay, I'm trying to show a GitHub link for the Walmart problem that I was actually talking about right now. Okay. I have them in here. So this is open public repository that I have. I could give the link if you think it would be useful for you. So yeah, here I'm dealing with the problem of understanding and forecasting the sales for the Walmart. And I have written the whole code in Python in a Jupyter Lab notebook, because it's really easy to visualize at every point. And mostly people who use data science and machine learning prefer writing in Python because it's really speedy, and you have a lot of inbuilt libraries, so you just don't have to write more code. You can just import libraries, and you can get done. You can get the work done faster, and you have a lot of data visualization libraries. Like you can just pull up a scatter plot by just calling import matplotlib, something like that, and you can just use that. So those are the advantages of why Python is actually used. And I'm importing some libraries here, and I'm reading some CSV files that I have for the data. And I'm just going to give an overview, and I'm going to explain it better in the next slides as I talk. So I'm just training them. I'm understanding what are the features given here, and what are the unemployment rate and things like that. And I have stored department weekly sales, temperature, fuel price, and other factors. Many are like, since because I was dealing with the Walmart, it was mostly US centric, and there are a lot of data factors that are different. So I extract things that was needed. I understood better in how it was performing. Say 0 to 25,000, it was more, and at this time it was different, and things like that. And yeah, so I understood what was important from the whole data set that I have. From, like, you will get, say, 1,000,000 is the data set size, and you can understand what column is actually needed for you and what is not needed for you, and you do some computation and you derive at the particular columns that you think are useful here. And then you supply them to, you separate the training data and the test data, and you supply them to a model. Here is just a one-line code for my model because I'm just importing it. I'm training them and testing them right here in 30, and I get some results. And I see how the store numbers are giving me results. And I was able to calculate some accuracy for the prediction. And if you could see, the accuracy of the model is 89%, 0.089. And here, so that is just a vague understanding of how there are a lot of technicalities in it. I can explain it further, but what I was trying to help you understand was that I am using Python here. I'm using it in a Jupyter Lab notebook, and if you could see the number of code lines written to understand the sales prediction problem was fairly less, because we are using a lot of inbuilt libraries, and we are actually taking the whole amount of data, separating them. And while I'm also using the Jupyter Lab notebook, the one more thing is that I could see my outputs at every point of time, and I would know with the scatter plots and data visual techniques that how it is actually performing at this time, how is the data here, and I actually have differences of data, so I am able to understand better rather than just dealing it with in a, say if I'm writing it in a Java, I would have to do the same thing, but the efforts are more, and most of the libraries are not supported and things like that. So it's even more harder. So I prefer it to do it this way. Okay. While I was talking about data science, I was telling, so this is a new thing. So what I have introduced now is that data science and computer science coexist with each other. We need to know about the basics of computer science and how math and statistics are important in data science. And now I'm going on to this new section about what are the facts that we have to follow, what are the approaches that we have to take inside a data science project. So I analyze the data, as I have said you about how we extract the features and things like that. Now I'm talking about training and the testing and prediction. So what exactly I do in training is that, say if I have 1 lakh data set, 1 lakh rows given from Walmart sales to help me predict. So in 1 lakh amount of data, I take 80,000 for training and I do 20% for testing. So what happens is that if you train a model telling that if you show, say I'll take an object detection example. If I'm showing a remote 10 times where it is, I'm not telling it's a AC remote or if it's a TV remote. If I'm just showing remote 10 times, and if I'm even showing the wrong remote, even I'm showing the cell phone as a remote for 10 times, even though it's not, the model tends to understand that every cell phone could be a remote. So when you're doing training, we have to limit. We always have this rule called 80-20. Mostly 80% is training and 20% is for testing to know how the model is actually performing on the training. So we don't try to overtrain the model because it would think everything is a remote. So whatever comes black or whatever comes white in a small shape, even Nokia 1100 phone could be thought as a TV remote or an AC remote because it was just made to be understood that way. So we have to really define what is the amount of data that we are going to train so that we don't overtrain. So I have an object detection example here that I'm going to talk about. So I have an object detection. I have a camera which has which is powered by computer ML vision, and you have to understand if whatever I show in that particular camera, be it an object, it has to be understood. It has to understand and tell what kind of object it is. So that's a basic use case that we're going to solve now. I'm having 100,000 rows of data of pictures, 100,000. So I have 100,000 pictures for every category. One category is clothing, one category is shoes, and one more is spectacles, and so many things like that. So when it comes to a remote section like electronics and a subdivision called remote in it. So electronics has 10,000 amount of data. So what happens is that if you train all 10,000, instead of just limiting the amount of data, if you just train all the resources wrongly, the model is set to perform wrongly because that is how you train the model like. So if you just show 30,000 wrong models and you label them as remote, and you tell them to understand this is a remote, it will understand that as a remote. So you have to be cautious about how you label the data. So you have to know if the data is right or wrong. So if the data that you give is really crappy, it would actually give us wrong results. So in the Walmart data that I was showing, there were many columns that were having unknown. So values like NaN, which is null or something like that, or it would have 0, or it could have something like a foreign character, where it is like you choose a column, tell location, you think it's an important feature for the algorithm. And when you take that, you also have to predict the quality of data that comes in the whole column. If you just think that the whole column is going to be useful, of course, yes, but you have to be particular about what is actually in the column. Say for that one particular row of that column has not one particular row, say if out of like the column called location, instead of the place called Ananagar, you just have some random fillers like ampersand percentage for more than like out of 10,000. If you have more than 8,000 wrong data entered, the model wouldn't understand when you have to actually predict. So you have to make sure the quality of the data you give is right and what kind of content is in the feature of the column that you select. So that is what I was talking about. And there's also a rule that I said that training is 80% and testing is 20%. So we actually split the data so we understand how the model is performing. And even when you perform training, we are being cautious about what we send to the data, what we send to the model, so that the model is not going to perform wrong because of the data. And those are the important factors. And when you test and predict, you give so testing is different and prediction is different here. So testing is what, so in that 1 lakh, 80 was training and 20 was testing, right? 20, I'm just testing to see if the model is performing right or wrong. So if I'm giving 20K data and if I'm telling that what is this object, and out of 20,000, 16,000 times the model said right for right number of objects. If I showed a mouse, it did identify that as a mouse, and that was right for 16,000 times. We surely know that the model is performing, say, close to 85 to 90% right. That is testing. Prediction is now the model is ready. You trained it on some amount of data. You're testing it on some amount of data. Now you're just gonna expose this model in a pipeline or in a fashion where it has to be, it can predict whatever. So the model is done, and now you can use it for prediction. Prediction, what I mean is that you can use it in the real use case. So if you have to put the camera in a store or in wherever to identify the objects, it would just work. So that is the prediction phase. So these are like the 3 important phases where we have to train, test, and predict. And this is how the thumb rule of training and testing is always 80 by 20. And the test data should not be exposed to the training data. So if I take 20,000 separately, and if I keep them away from the model is not at all exposed to that 20,000 data. So when I provide the data to the model, it is able to understand that, okay, this is not the data that is in the training set that I had. This is new, and I can predict that this is a mango or an object or like a computer or whatever. So that is how training and testing work. And okay, so here I'm going to talk about how a pipeline actually looks like in industries. So when I tell pipeline, I will put this use case of understanding recommendations in a website. So I work in this company called Rakuten, I was telling. So it's an e-commerce company that specializes in affiliate marketing. So we have a lot of e-commerce customers for us. So when we talk about e-commerce, when I am shopping in Amazon or in some other sites, what I do is that, so when I look for a t-shirt, you always find like something you like this similarly found. and you get another section. Say if I'm looking for a t-shirt and the t-shirt titled like Yale or Harvard or whatever university, IITU, whatever, you get similar t-shirts, the same t-shirt but with a different design or with a different with a different model to it, but it's pretty much the same color or things like that. You get a recommendation of what they think you would like. So this is the use case that we're gonna look about, and I'm gonna tell you how that use case is solved in a day, in a company, in an industry, in an actual pipeline fashion. So we have a catalog data. What I mean by catalog data is that a data about all the number of products that are in a website. And now I take data from the website, and so I have a catalog information in a database. So that catalog information is set aside. So amongst the catalog information is the data where I have to use for the model training as well. So I have a database and I collect. So okay, yeah. So I collect the data, I extract that particular table which I think is relevant. I do 2 joins or 3 joins, or maybe because data is not actually kept in one table, right? You actually distribute it across multiple table, and you just have to join different tables to get the actual data. You join like say close to 5 to 6 tables, you get some amount of data and you put it in a different table for your understanding of that problem. So you combine that, you collect the data, and you do a bit of pre-processing here. So what I mean by pre-processing is that you have to see if the data is really relevant for you, the rows and columns you think it's necessary, or if you're dealing with e-commerce data for recommendation, and if you have some irrelevant data about books which you don't think that's a part of the segment that you're dealing with, you just want to deal with clothing and recommendation system for clothing, you just cut out all that. You just do some pre-processing to understand what is actually relevant. So you take the catalog information from the database, do some joins, keep it in a particular table, and you do some pre-processing to understand if that data is really necessary, and then you go for the data prep. So as I was telling, say I was talking about foreign characters and ampersand symbol and things like that. So you clean the data, say you have like 100 rows and 100 columns in the table. What do you think is what do you think? So if you have like a lot of empty values in many tables, you just cut them off and replace it with nan, or however you think you have to deal that. You have to take them away completely and things like that. And you take features out of 100 rows and 100 columns, which do you think is exactly needed for that particular data science problem. You take them, and then what you do is that now you know you're dealing with recommendation use case for clothing, and you have amount of data, you cleaned it and you're ready to go, but now you have to choose a model. So this is a really important step. There are different models available in the industry. So for say, if I say a recommendation system, I have like 5 models for it. You can use convolution neural networks, you can use RNN, you can use so many different models that could use in that particular scenario. Like for recommendation use case, you have to do a mini POC to understand what model actually fits your need. Okay, this model called CNN will work better because I'm trying to identify patterns. I'm trying to find a close match. Say if you have seller A trying to sell the same t-shirt and seller B trying to sell the same t-shirt, I'm trying to if you're using that seller A's t-shirt, immediately in similarly found, you have to find seller B. So you have to do an image match, exact match. So you know that to do this, CNN is most popularly used, and you do a mini POC with just 1,000 rows of data, and you see that this is going to work, and you just understand and explore and select the right model, and then you go to the step called training. As I was telling, Okay, I'm not sure why it's turning on. Okay, so it's telling you have to select the amount of data. You do this 80-20 thumb rule. Some people try to do 70-30, but I suggest using somewhere between 75 because no one can decide actually what is the actual number that is needed because everyone has a different kind of understanding with this training and testing. You take the 70K or the 80K amount of data in the 1 lakh rows that you have, and you keep them separate for training, and 20 is taken completely and kept separately for testing. So the testing data is not at all introduced to the training, into the model at all. So you're just gonna start training. And then once you're done with training, what happens is that you do some fine tuning. What I call fine tuning is that you apply few parameters to the function to reduce the training loss. As we all know that when we run a particular model, there could be some amount of loss that can be possible. So you just run some parameters to minimize and accelerate more of the performance for the model. You just do things like that. And then you do testing. You take the 20K data that you set aside for testing, you test on that. For the 20,000 use cases, when you ran the model on, it was able to give the right recommendation. Okay, out of 20, 15K performed well, so you know the data is like 90% accurate, and then you put them in a deployment phase where you think you just dockerize. So whatever you're using or whatever you're doing, the code that you write on your local machine cannot be just consumed. So you have to put them in a Docker, which is a cloud-based understand. So to tell you, so I particularly need say 10 libraries. Say what I mean by libraries, the import statements that I use. So if I'm using 10 import statements, there are 10 libraries that I'm using. So what I would have done for using those 10 libraries is that I would have downloaded those libraries. What I mean by download is my Python version. I do pip install. My Python package manager is having all the libraries. So when I suddenly run the whole model in a different environment, you have to install and set the Python environment to that particular version, and you have to install all the libraries in that particular location as well, the same as we do in Java and other languages. So you have to put them in a Docker container, which is a cloud version of the whole code being written somewhere, and you just can put that in a place, you understand how it is working, and then from there, so you always have a feedback system in real-time use cases like this. So you also know whenever the model is telling this is right, you also know when the model is telling it is right, and you also know when the model is telling is no, but it is actually right. So suppose it was a right recommendation match, but the model showed wrong for some reason, you get it back to the model and tell model you were wrong and please learn from this, and you give it to the training batch. So from the inference, what happens is that whatever you do from the inference, it comes back to the data and you again supply it to the training. So whatever you learn from there is always a feedback loop that runs behind. So where you understand that even though the model is not performing well, you just make sure that they understand these cases in further and they're able to perform better. And you put them all in some code in a pipeline, and that is how the overall thing looks like. And okay, why I am a data scientist? Because I think it's really not boring and it's something really interesting for me, because I cannot, I'm very curious by nature. I'm very anxious too. So it's really hard for me to sit and work on something which is already like a proven fact, or like people know about it. There are more of research and exploratory parts of data science which I'm really interested in. That's why I think I want to do that, and that's why I'm in it. So okay, there are different types of data science roles actually, to be talking fairly. So there could be like, you could just be named as a data scientist, but you would be doing something else. So I'm here to talk about how in industry people are actually oriented towards data scientists, and what they actually do in a data science role, and what are the different variations of it. So even if you're a programmer, there could be different variations, like where you would be programming just front end, you could be a back end programmer, you could be you could just be writing some service layer, or you could just be even like a cloud application programmer, or there are like a lot of different things even being a programmer. So there is even like DevOps engineer who is still a programmer and a DevOps guy. So there are a lot of variations in the existing job roles, right? So even with data scientists, there are more of like difference in the same role with a lot of variations in it. So I was wanting to talk about it. Okay, yeah. So the first role, the reporting and the ETL analyst. So what I was telling about ETL is extract, transform, load. And you have a database where, say, if you're using a database to, a three-dimensional database, I would say, for a better understanding. So I have a lot of data about uh, catalog information of shopping or e-commerce or things like that. Being a data scientist of role type 1, what the person would do is that they would understand, okay, data is stored in this way, the architecture of the database is not really great, so you could modify that, or you would understand that this particular this particular table is connected with this table, and you could derive insights from this table and store it in a different table. Say you have a catalog information of shoes data, and you understand that some shoes could be used for like some season. Say if you have boots, you would only use it on the rainy season. You would make some predictions or some analysis about the data, and you would store in the same table itself in the database, so that that could be used for some other reason by some other team. So there are data scientists who just work on a database specific role, so that they understand all of the data and every part of the data that's in the database, and they transform them and make sure only relevant information is there, and they are more insightful rather than just some random data. So they make some transitions in the database and they get more insightful data. That is role type 1. And role type 2 is data science generalist. So this is different. So they would just be doing, as I was talking, the whole pipeline. So they would be doing like all of the steps. They would be doing from the start to the end. Like they would take the data from the database, train them, test them, select the right model and deploy them and things like that. That is type 2. Type 3, insight analysts. So these people closely work with people like CEOs and a lot of like executive people, where you work exactly on understanding. So if I'm talking with my company's CTO or a COO, or understanding, they would ask me, okay, how do you think the COVID is going to affect our sales, and what do you think are the features, or like other categories where more sales could be actually be targeted, and what do you think, where do you think we should run our promotional events for this particular category? How do you think we have a lot of categories that are not at all, no one is buying that. Say like if I'm having something like a swimming pool gadget, or like swimming clothes or swimming pool accessories, no one is buying that because we're not allowed to use the swimming pool due to COVID reasons, so the sales would be really low. And how do you think I could accelerate that, or what do you think is happening in it? When do you think the sales would go up, or factors like that? I would be talking to a lot of executives, and I would be giving them insights on to help them drive decisions forward. I would be working on a lot of different questions that could be possible, could be useful for the management and to drive the focus around. So I would work and get some analysis on every particular possible information. I would have them with me. So that is role type 3. Role type 4, this is the role type I'm actually doing. uh, the ML research data scientist. So you do a machine learning research being a data scientist. So as I was telling, machine learning and data science are so interoperable. They are fairly two things that coexist with each other, and they are like, interrelated. When I'm telling ML research, I'm talking about understanding what algorithm would work in this scenario, or I'm just having a use case, I don't know which algorithm to use, and what do you think this data could be transformed. Like, you can just do a lot of POCs around a lot of different ideas that you have, and you could see if this is going to work or if this is not going to work. If you think that's going to work, you could just give that to role number 2, who will be a data scientist. You just research on something, you tell that this is more insightful, and you can just give that to a data scientist, and they would take that model on, train, test, and clean the data and do all sorts of things. So another person, like type 4, is just a researcher who reads a lot of IEEE papers and understands, like, okay, this is the particular model that they're proposing to solve this change. Okay, let me implement this model and see how it's working. Okay, do I think this is the right model for this amount of data, and things like that. So that's role type 4. And role type 5, you would be a software engineer who also uses ML. So if I was talking, as I was talking about here, so I'm given a data science model. I don't know how the model works, but I have to actually wrap things around the model. Like, I have to make sure the data that comes off the model is displayed in a website, or like, as I was talking, we were talking about some recommendation system for clothing category. So if we have the result of that particular ML model that is coming out, how will I pass that to a website? Or so I have to understand how the model is performing to understand the results. And I should also know basic coding to make sure the results are being published in a website or in a fashion or in a different place. So I have to know a bit about the model, and I also have to know about the actual coding practices. So that is role type 5. And role type 6 is platform in the warehouse engineer. So what they actually do is that they wrap around. So you think particular training, the data taken for that particular model is stored in this particular database, and you have a different platform. So you're using a VM. You just spin up a VM. You just spin up a GPU, graphical processor unit, like a CPU, but with a lot of different resources, so that you could run your data and your programs on that. So you have to understand more of system specifics, and you have to know more about what are the resource allocations for this particular NVIDIA GPU that we are talking? Do we actually need CPU? Or how do you think you can deploy this model in a Docker? As I was talking, just importing your code from a local machine in a cloud location so that it can run there. Or how do you think the Kubernetes and the containers work? And things like that is actually role type 6. They know what the data science is, and they're able to push them in a different location, and they can make sure the deployment is successful and that model actually works in a different location, is role type 6. And role type 7 is actually data science specialist. So they focus mostly on one area, like training more or testing. They understand every particular use case, and they only work on, like, say, I only work on some use cases like image, or there could be some data science specialists who only work on images. Like, they would be even named like vision data scientists. They only work on computer vision related stuff. And there are some data scientists who only work on augmented reality or something. There are more specific arena. You just pick that and they stick on to that particular models and process that they could follow. So that's role type 7. So there are different types of data scientists in nature. It's not just like every role is similar. There are a lot of variance here, and there's a lot of scope in it. So why I was explaining this is that to make you understand understand how interesting it could be like, and what are the actual scope, what it actually looks like in an industry, so that it's even more relatable. So yeah, that's about data science role. And okay, yeah, I won't go there. Okay, let me go to my GitHub so that I could show more in detail about what I was talking. I'm going to choose another repository to help you understand better. Okay. We were talking about text recognition, and okay, give me a minute. Okay. I'm going to stick with my Walmart sales prediction. Seems like I don't have the updated code here. Okay, I'm gonna go cell by cell to make you understand what actually a model file looks like and how it would work. So here, okay, going to my first cell. Okay, so I import this package called warnings, and I tell ignore the warnings, because when you're using some versions of library, there are more warnings that could get printed in the logs, which is actually noisy, and I don't want to see that. So I have this in place, and you could see I have a lot of different libraries in here. So the first one is NumPy, pandas, and there is something called SciPy. Like, it gives a lot of statistics ability. This is for plot labs, like I had a scatter plot down below, so that was for that. And this is scikit-learn, and this is also a different kind of library. And here we have the style for that particular plot graph. And here I'm actually importing linear model, my actual model that I'm going to use in this data set. And here I have a cross validation. I'll tell you what cross validation is when we go down there. And we also have some preprocessor for some data. So these are all the libraries that I import. And okay, so what I have done even before going to the model is that I have separated my train data and my test data in another program. So you write a program where you get like 100,000, like 1 lakh data, and you split them into two different categories, train and test, so that it's easy. I already did that, and I have two CSVs. This is train.csv and this is test. And I stored them in this particular, I have another CSV called store. It contains store data. And this is features. So what features I think is useful, that particular feature information columns in here. So train.head, head is nothing but it shows top 5 records, 0 to 5 records, and the number of columns and rows in it, like the top 5 most things that you have. Top all the columns, but just the 5 rows of data. So we have 5 columns and 5 rows of data. And this is store 1, department 1 on 2010, May sometime. No, February sometime. The weekly sales number is this, and it's not a holiday, and they did not have a holiday there. They had a holiday, but still the sales was $46,000. And this, and this. You have different dates and different sales, and you also know that week had a holiday or not, like apart from like the regular holidays. Like the store can close on a government holiday or something like that. And you extract features. So from the feature file, you also extract top five rows. Yeah, I tend to interrelate. Store date, the temperature of that particular day. So if it's really hot, people try to do not store purchase. They could do an online purchase or something like that. And Walmart also sells fuel, so the fuel prices. And there are some random fields called markdown, which does not have any value, but we have the data. We have a value called CPI. It's customer purchase index. As far as I know, how the average number of average bill a customer would make on that particular date is somewhere like this. And the number of people who were unemployed at that particular store, would that affect sales or something like that? Is holiday true? So what I do is that I have a feature data and a training data, and I try to merge this. I do an inner join, just like how we do in SQL database. I just do this using pandas in one line. I merge them, and if the store and the date are same, and the rest of the features would be same. So now the merge looks like this. So this is the merged data. I have store department, this and this together. Both of those columns, 9 and 11. 9 and 11 together is this, 13. You have all the columns in here. And I am doing a transpose to here. I'm doing a transpose because it's hard for me to understand like this. So I do it like this. And I also have some, so if you use this describe feature, you know, mean, average, standard deviation, percentage, what is the maximum value and things like that, which could be helpful. So the maximum temperature on that particular scenario was 100, and the weekly sales count maximum was one day it just went like $6 lakh something. So for some reason, and yeah, so there are a lot of factors where you could understand what is actually helpful here. And I imported date and time, and I'm trying to take that particular date and time. Okay, using this date and time, I understand how the weekly sales, you call that, okay, how exactly the weekly sales would look like. So I'm just trying to plot a graph just based on the data, not any predictions. I'm not even going to the prediction. I'm still trying to analyze more of data, how it actually looks like. On 2010 fourth month, we had the max touching like 150,000 for sales, but or some other dates you even went to $2 lakh for some reason. And yeah, so you take the store, you do the date, and you can understand on this particular store, on these dates, these are the actual weekly. So what you do is that the daily sales, you just put a weekly sale detail here, and you understand how it works like. And let me go to the actual facts. So I also do a lot of computations in here. So I'm trying, so if I had a value called true false for is holiday. So holiday was true false. So when I actually send it to the model cannot understand true false. It need to be binary. It need to be a number. So some models have some features where the independent variable should be a number than a actual variable. So I convert it into zeros and ones for them to understand. And yeah, I still perform. I see what are the unique values in here and things like that. and I separate the training and the test data on a random manner. So from the training data again, I split apart for testing just to make sure that the training data is completely so in the amount of data that I already separated for training and testing, I also have a small subset called test again, just to make sure that the training is working fine and it is having that particular index. So I again split that and I see. So here I actually apply my model. So if you see here, I only take relevant columns that I think are useful for the model to understand. I just don't dump everything. So I only extract what I feel is relevant after the analysis. I apply it to this model. I supply this thing called X-train and Y-train. And after that, when you do a graph plot, from here, okay. So I now know how the data set is predicting. Now I'm passing it on to the test set, and I know how. So my prediction is this, and data is around. The red is the actual things, actually how they thought the data is like, and my model is actually predicting it right. And I have an accuracy number. Again, there are a lot of inbuilt libraries here, so I just have to run an inbuilt library to understand the accuracy of my model. And there are, even in accuracy, you have something called sum of square, MSSE, mean square, some prediction and things like that, some factors where you think could be useful. So yeah, I have the percentage here. The 89% is my accuracy for that model. So yeah, that is it. So that is how actually a data science model looks like, and how we train, test them, and how I was using Python and how I was using Jupyter Labs in it. And yeah. So I just wanted to run a background through what actually looks like in industries than usual, because sometimes it is like overhyped of what's happening inside the industries for data science. People think like everyone is a research scientist, but mostly we have very few applied scientists, and many people have different roles. So that's why I even spoke about different roles, so that we are able to understand what actually a data science person works like. And how did I become one? So when I was working back in India after my engineering, so I was doing a lot of R&D projects in the company that I was working. So I was working in this R&D team where you have to do a POC for every 3 months. So in the span of 2 years, like 24 months, I would have done like more than 10 POCs, 10 different projects. One would be like create a real-time dashboard with some real-time data that you're getting, and do an ML or something. Like every 3 months it was one POC, because I was working in an R&D team. So that gave me an exposure of AI then. So I understood that, okay, I had what is AI. I was doing something called cognitive behavior. I was understanding the sentiment for that chatbot and things like that. So I was able to understand things better. So I thought I should pursue a degree in AI so that I know things better when I actually work with them. And that's when I chose to do my master's degree. And then I got admitted in University of Texas. I did major in data science and AI. So while during the course, I was also interning at this company called Red Hat. So there also I worked with a R&D team, a research lab, where I was an applied scientist there, and I was understanding more of data science again. So yeah, that is it. And I thought this was even for students. So I also have this in my slide where I tell how you actually get into masters, like what you actually do after your undergrad to help you get in the right direction. Because sometimes it's really hard to understand, should I apply to the college first, or should I get my loan first, or should I choose which country, should I choose which college, or things like that. So I just made it in phases so that people are able to understand better. And yeah, um, that's it. And I'm open for questions.
Participants, those who want to ask any questions, you can ask the questions.
Yeah, it was a good presentation, Mr. Smita, ma'am.
Thank you.
Yeah, my thing is for us, what tools is best for working in big data, sensors data?
Can you say that again? It was not really clear. I'm sorry about that.
Yeah, I want to know the best tools for applying sensors data.
Best tools for applying?
Sensors data.
So we have to know what you're actually trying to get out of the data. So there are multiple tools in recent times. So you don't, whatever I did in the Python notebook that I was just showing you, so I didn't want to jump more into code because it's even more little complex. That's why I just showed you a guess. Many of the code lines that I just wrote are even present in a lot of tools like SAS. You have Tableau, you have Domo, and you have BigQuery, you have Google Data Studio, and you even have something with Amazon. I'm not sure. So many of which I mentioned are free and fewer enterprise versions, but they are actually used to understand data. So you can just put the data there, and there are even free versions of SAS which you can get in universities. You can just give some random data sets for students where they can just go inside that particular SAS, upload the data, and using data from column X and column Y, you can understand some data and you can make some graphs in it. So you have a lot of tools for data. So you can just take census data, load them in the SAS or something like that, and you can understand better. Okay, you can think like, okay, this histogram of number of people living in this area have this particular thing, or whatever you're trying to understand or get an insight for. You could just put that in a tool, and you can just, with visualization, it gets even better, because when you are talking about census data, it could be more than more than 3 to 4 GB. Like, it would be really long and huge. So in that case, I would suggest going for a tool, because when you try to understand all of the data by looking through the Excel, it's really hard. That's why they have a lot of these tools, like I mentioned, SAS, Google Data Studio, Big Data from Big Data Query from BigQuery from Google Cloud, and you have Domo, and you have Tableau, and you have a lot of things. It's very UI friendly. You don't even have to write a piece of code, and even the code that you have to write is very minimal, and it's like a plug and play. You just have to pick join from one particular thing, you have to pick another particular condition, say if that particular thing, and you just club, and then you get a nice graph understanding, okay, how X and Y are related. So it's even more easier. So this is what people in industries, like especially business intelligence engineers, so they work on understanding the data, and data analysts, they actually use just to understand data, not going very technical or things like that.
Yeah, thank you very much.
And Sushmita, there are a few more questions in the chat bar.
Sure.
That is in chat.
Okay, so I'm starting with the first question. So supervised and unsupervised. So it depends on the scenario where you want to use supervised or unsupervised. So as I was telling, say we had an example where we were talking about clothing data or a recommendation system for a t-shirt, right? So you just give an image. how do you know that image is a t-shirt or not? Someone actually labels that data and they give it to you. The label is being done by an annotator. So in Amazon, there are a lot of people who work like catalog associates and other few roles where people actually label data manually. So they just see a data, say if they see a cell phone, they just go to that particular image and they add the detail called cell phone, Android, and they write a lot of features, black, and they write like, okay, it is 5 inch, and they write the make like Samsung or whatever, and they write a lot of features about that thing. And when you actually use unsupervised, you don't have labels, so you just have the picture, you don't have any information about the picture. When you use supervised, what you know is that you know that is a mobile phone, you also know about the features, so when you give it to the model can understand better. When in unsupervised, even when you don't have any information about that particular data, like an image I was telling, unlabeled data, you go for unsupervised. So they are basically supervised and unsupervised for those reasons. So when you're not able to label a data, you really go with unsupervised. So even whatever data I was talking, even the Walmart sales data that I was talking in an example before, everything is labeled. So what I mean by labeled is nothing but someone actually gives you more information, right? They write more information about that particular data. So you know about the particular data called CPI, which is customer product index. You wouldn't know that if you just grab some random data. So that label for that particular thing is given manually, or sometimes it's even machine done. So if you don't have the label, it's different. If you have the label, you can use supervised. If you don't, you can use unsupervised, because even when you don't, the model itself has the capability. So unsupervised are mostly like CNNs and RNNs. So if you take a convolution network and recurrent neural networks and things like that. So in such scenario, the model can understand better on okay, even though when you don't understand data, they do more understanding on every feature of that image. Oh, okay, if it's this shaped, it could be a cell phone. They understand more from the data rather than the data, rather than the features of the data that we provide. So that is the thing. And which machine learning classifier gives good accuracy? So there are so many classifiers like random forest, so many different classifiers that are available. So first we have to, as I was telling, we have to see which suits our data. So what I was using for Walmart example that I showed you before was linear regression. People also use logistic regression, but the results could be different. So every algorithm is different for different data. So we have to definitely do a mini POC to see if that really works or not. So we don't have like standard algorithms for every problem. For every classification problem, we cannot go with linear regression itself. For some, it could work. For some, it could not work. So it solely depends on the data that we are using. So yeah. And whether research in data science is PhD gives more opportunities in this area. Again, it depends. I'm a very industry-based person, so I am working as a data scientist come applied scientist. What I mean by applied scientist is that I do a lot of research work that I was mentioning. I do a lot of POCs of understanding what from IEEE papers that which algorithm works in what scenarios and things like that. In PhD, you could be doing something similar to that, but sometimes not, because you might just be reading more about research papers, but you wouldn't be dealing with a lot of data, because when you don't work with industries, you wouldn't be exposed to huge amount of data. You will just have academic data that you find from internet like Kaggle or things like that. So the academic data is very limited, and when you perform these experiments, you might not understand more and you might not get more information. That's my point of view. So when you work in industry, you have real-time data. I'm working with the data for the current project that I'm in, which is close to like 3 TB. 3 trillion. I'm sorry about TB. 3 trillion. So the catalog data is so huge that when I'm working for that amount of data on my model, I know how it works like. So rather than just doing an academic experiment, I would prefer going industry-wise. So yeah. Uh, there are many popular supervised learnings, like as I was mentioning, logistic regression and linear and things like that. There are also a lot like decision tree, random forest, and there are a lot of supervised learning. So it again, so even in supervised or unsupervised, you have problems like you have a problem called classification, you have a problem called entity recognition, you have like there are different problem cases in every. So in classification you have 5, in entity recognition you have 4, you have different algorithms for every problem. Even in supervised you have a problem scenario. So that is how we could address that.
Hello.
Yes.
Yeah, you have explained about many Walmart data science, and
Mm-hmm.
while analyzing the sales record, nowadays the emotional factors also coming under one kind of factors to be considered in predicting the future sales analysis. So, have you ever considered this emotional factors in your analysis?
Yeah, yeah, that's actually a great question. Thank you for asking that. So as I was
Yeah,
telling,
since nowadays this data analysis striving to the platform of emotional factor. I have studied many articles. So, have you ever considered this emotional factor? Is there any scope to extend this emotional factors in further?
okay, so when I was talking about the recommendation system that we were talking, like the recommendation for a T-shirt or something like that, emotional uh, features or emotional data for that particular model is not at all required. But again, when you take in consideration of sales or sentiment or things like that, emotional data, like what you talk about, emotion is basically like sentiment, how important it is, how the customer is actually feeling, what is the review of the customer. So you don't show a customer a product which is like having 2 reviews, 2 minus reviews. You actually show the customer the product of what is like having more than 10,000 reviews, right? So that actually is a kind of sentiment there. So you understand, so in the comments that they write, you know which comment to showcase first and which comment to showcase last. So there are also things like that. So if you use some articles, some word of articles, like if you use good, great, or like good positive emotion words, they come in the front. And if you use like the product is pathetic and it is not actually great or things like that, it could be in the last sections of the review. So there are also emotions considered. So it depends on the use case. So you don't have to use an emotional feature if you're trying just an image classification algorithm, but you have to use that if you're understanding about or if you're understanding the customer's mindset of buying the product. Say if you're trying to buy a bed frame, like a bed for something, and if people are telling that this wouldn't fit, it would break down in between or something like that, so you would understand. So it depends on what problem case. So not for everything it's considered, but nowadays definitely when we are dealing with review system and things like that, it's really important to understand that that particular customer, what he has given reviews and things like that. So yes.
Yeah, and one more forthcoming question.
Yes.
Have you said that this COVID factor really affected the online market? Really? Have you analyzed that this due to this COVID?
Yeah, so I actually don't work on the sales front. So there are other data scientists who work on the sales front, like who have to report to the executives, and they have to maintain like a momentum. So every week they come up with a new strategy, like, okay, this week more of like home decor is like, more prevalent in this particular week. So we we can try to market that more. We can try to put more sales for that. We can give an offer, 50% offer for home decor, because everyone is sitting at home. They want to make home feel really good and nice. So like reduce home decor like this and things like that. So there are like a set of scientists who work on that. And that is actually, if you take Amazon, that is how they work. So they have a separate team designed for that. And even in my company, most of the companies have a separate team designed just for that particular use case, so that they can brief the executives on that particular standpoint, and they can understand the customer behavior even better.
Yeah, fine. Thank you, Sushmita.
Yeah.
And thank you for the participants, and thank you, Sushmita. Um, I would like Sushmita for accepting our invitation to handle this session on this FTP. And I also I would like her to get her success in her life as well as in her career. So all the best to Sushmita. And I would like the participants to be joined by tomorrow by 9:50 a.m. So most probably the invitation, it won't be accepted after 10:15. So you try to join before 10:15 a.m. and don't try to join after 10:15. And thank you for the participants, and thank you, Sushmita, for your wonderful presentation, which you have been given. And as an information I can give to the candidate participants that along with the Python programming, you have the other tool also, which is nothing but R programming. So that's also, it can be used for the statistical purpose. She would have been lifted. Apart from that, she has said about SAS, Tableau, and everything she has mentioned. But one other tool I want to add to that is an R programming. That also, it will be somewhat easier for you. But people who are working in a Python programming, they will adapt only the Python. They won't go for the R or some other packages. And thank you for everyone for attending the first day of this FTP. And we will be meeting by tomorrow by 9:50 a.m. And thank you, and thank you, Sushmita, too.
Thank you, sir.